The next, we come back to a very crucial concept. Functions. That is user defined functions. Now in any program we have assumed that we know some programming language like Fortran or BASIC or Pascal, and in all of these languages you can use functions. So you will, in a program, say in a C program, you will have a main program and maybe you will have an integer n, and maybe you will call a function say xx with argument n, and then do some other things and terminate, and you will declare a function xx with argument I, and then you will do something in this function. It may be a function, some people call it subroutine also, because you may not return a value. In C language everything is a function, and you can return values through the arguments in a special kind of a way. Before we move into C language examples, let us clarify some terms. There are two parameters of a function. One is called the actual parameter, and this is called the formal parameter. Because this xx may be called many times with different actual value, actual arguments, and this is the formal parameter wherever the function itself is declared. The type of the two must match. If the types do not match, there will be problems. Obviously you can have more than one parameters, and here also you must have the same number of parameters. You cannot have less or more, and their types should match in a one-to-one fashion. This is well known. So now let us see through an example what happens in a C program function. So let's take a very simple example. The first example will help us to understand the syntax of calling a C function as well as the way a function behaves. So here I have got a main program which ends here, and I have got a function called fun1 which ends here. And now what do I do in the main program? I do int abc, then I read in three values, scanf and a and b and c, and in these three values before the call I print what the values are. I call the function like this, fun1 abc. I can call it, I can do an assignment also, x equal to fun1, but we will see that later on. And then after the call I again print the value of the variables, and inside the function corresponding to a I have I, to b I have j, and to c I have k. And before the brackets open for the function I have to declare the type of the arguments. I can declare it here also inside the declaration, I can also declare it below. So I use the approach of declaring it below. We will see examples where we declare it there. So I have declared them to be integers, and inside the function I assign I equal to 21, j equal to 22, and k equal to 23. I need not put them in separate lines, just semicolon takes care, so that's fine. And I put in a print statement that inside fun1 I, j and k are these. Alright, so this is a very simple program to understand what the syntax of a function definition is. The syntax is the first the function name, the arguments, then the type, and then the body, and the body again comes in brackets like this, just like a main program. And here I have just read in three values, and before the function is called I printed it. I called the function. Inside the function I printed it after assigning it, and this is what I have done. If such a equivalent program was written in Fortran, then whatever I would have read would have been printed here. Inside the function they would have been converted to 21, 22, 23, and after the function call they would have been converted to 21, 22, 23. But that's not what will happen in C. So I'll read in three values, 2, 3, 5. Now what do I get? I get before the call it is 2, 3, 5. That is what I have read in. Inside the function, obviously after assigning it to 21, 22, 23, and after the call it is 2, 3, 5. So I did not get a change when I return back. That is, before the call whatever I read in I got. In the function these were reassigned, and after the function they were returned back. So why I did not get a change is the first question. And if I do not get a change, then what is the use of calling such a function? Or how would I get a change if I want such a change? Are the questions that we will have to answer. Because if a function does it requires some values, and I may want some value to be updated, how would I do it? So to answer this question, first we will have to see how function parameters are passed in C. What are the ways in which function parameters can be passed, and how do I get back values in C if I want to pass the function parameters. That will also give us some hint about why scanf uses this AND. So let's go back to our workbook and see what we can do. So we've got the actual parameter here and the formal parameter here. Now in any programming language we shall see that when there is a function called, say, fun1 a b c, there is a call, and we have got the actual formal parameters as I mentioned before, I, j and k. Now these a, b and c are occupying some locations in the memory. So schematically let us say A, B and C. Now when this function is called, a new data segment for this function is set up. The variables, the arguments, as well as the local variables of this function are allocated certain amount of memory, of which other than the local variables I, j and k are also allocated some memory locations. In C language this is what exactly happens. When a function is called, this memory is allocated. The value of A is copied into the value of I. The value of B is copied into the value of J. The value of C is copied into the value of K. And then this starts executing. After the execution is over, this memory is deallocated and the values are not copied back. This is how C programming works. This is called call by value. This is called parameter passing using call by value. C uses call by value. So they are copied into the local variables and the function is executed, and after the function is over, these are deallocated. We shall see how this allocation and deallocation and memory access is done a little later on in more involved examples. In other programming languages, there are slight variations. There is a variation called call by value result. What this does is, when the function is called, it copies the parameters, arguments, executes this function, and after the execution, before deallocation, it copies it back, copies the new values back. So that is called call by value result. And the other one, which is used in Fortran, is called call by reference. What happens here is, instead of these values, these locations are not in here, these are not actual locations, but these contain addresses to this location. And whatever you do here, whenever you update I here, this address is taken and this value is modified. The modification is done on the content of this address here. Alright, so if you write I equal to 5, then here there is a change. It uses this location to keep the address of A. It uses this location to keep the address of B. And it uses this location to keep the address of C. And it uses this address to modify the contents. So it does a star I operation whenever an I operation is given. So if you want to change something in I in the function here, it uses the content of this, it modifies the content of the address, which is something called indirect addressing, but this is what is called call by reference. There are other ways of parameter passing like call by name and others, but we will now concentrate on call by value, call by value result, and call by reference. And C language uses call by value. So C language uses call by value and not call by value result or call by reference. Anyone who knows Pascal will know that in Pascal you can define this parameters in another way. If you write fun1 var I, then this means that this will be used as call by reference. If you write simple j, it means call by value. And again if you write say var k, then it will mean call by reference. So in Pascal, if you had written var I, j and k and done this, then this would not have changed, but this and this would have changed. Whereas in C, everything is uniform, call by value. So we'll have to see next how we make it call by reference. To make it call by reference, what we do is we pass the address location and modify the contents. Alright, so let's see in this example how we will convert it to call by value. So here what we did was we read in A, B and C. This is the value of A, B and C, and we passed in the to fun2 we have used another function called fun2. We have passed the address A and B and C and printed the values after the variables. And in fun2 we declared I, j and k, but we now have to declare these as address locations rather than variables. So this is how we declare it: int star I comma star j comma star k. To understand what this means, a very simple logic has to be applied. What does star I mean? Star I means the content of I. So it says that the content of I is an integer. This means the content of j is an integer, and this means that the content of k is an integer. Understanding it this way will take us one step ahead in understanding all declarations in C. There are a lot of intriguing issues for declarations in C. We shall see them slowly. But here what we have done is we have done this, and we have done star I equal to 21, star j equal to 22, star k equal to 23. We have printed the values of star I, star j and star k and come out. Now let us see what should happen. Let's go back and just work it out first, and then we will see. So we had a call now fun2 A, where we passed and A and B and C, and here we had fun2 I, j, k. So the three locations which will be copied here into I. Here I will have the address of A in I, here I will have address of B, and here I will have address of C. So this address of A, which is here, will be copied in, address of B will be copied in here, and address of C will be copied in here. These are the parameters. What is the value of AND A? AND A means the address of B. So once this is copied in here, it does not matter whether it is copied back or not. What I am going to do is I am going to modify the contents inside. So those contents are going to change anyway, and I am going to get it back reflected. So that's exactly, so we'll just quickly see the program. So what I've done is I've passed the addresses A, B, C, changed the contents, and so now if we run it, so now before the call it is 1, 2, 3 inside the function, and now I have, though it's called by value, I have made sure that after the call I get back the correct values. And now you will appreciate why in scanf you have to pass the addresses, because it's called by value. If you had passed A, B and C, whatever you read inside wouldn't have been reflected back when you returned. So that is why you pass the addresses, and the scanf function actually modifies the contents. So whenever we want to get values back and passed back, we will have to use the contents and the address locations in C. This is a typical C style of programming. It is unlike in other languages like Pascal, where it is slightly different. In Fortran it's pure call by reference. In C it's call by value, and if you want reference calling, you have to do it this way.